Hi, myself Ankit Thapar. I am in the last semester of the CPA program, Computer Programming and Analysis. Today I'm going to demonstrate the assignment once. So basically first I will go through the code and then I will demonstrate how it basically works. So what basically we did in this assignment is we developed a parallel binary files processing system. So basically we have multiple processes which will be like processing and basically reading the binary files, and then at the same time we'll be monitoring the memory usage. So based on the memory usage we'll be sending different signals. So overall that's like what we developed. So I will just go through like the different files, basically different functions we developed. So first is like the generate binary file. So as the name suggests, it basically generates a binary file of the given size. So whatever the size is there, it generates based on that. So first we did is we just open the file. So if there is an error like fd less than 0, just basic error checking. So here we have declared a buffer, an array buffer, basically which is of size 1 MB. So let's focus on this inner loop. So basically what this loop is doing is like, because we have this array, so basically it's filling this array. So we are filling it with the different bytes. So we are making use of this rand function, basically which generates a random number, and then we modulus 256. The idea is to generate a number from 0 to 255, which can be represented by a byte. So that's the idea, and then we just write it, and just again the basic error checking that the bytes we expected to write, are they actually equal to what's actually being written. So maybe like the actual bytes which we supposed to write was 1 MB, but the actual written is 800 KB. It means like, so there is some error, right? So just the basic error checking, and then we just close the file descriptor. So let's move on to this one. So this is basically the main part of the assignment, I would say. This is just a helper function I have just declared. So what it does is like, if we just like give it a file name, like let's suppose worker1.bin, it just extracts the integer out of it, like 1. So the idea of this function is, because we need to like print in the end like worker1 completed, so just to extract the integer out of it. So this is the main function. So overall what it does is it opens the file in the read-only mode. So whatever the file name is provided, it opens the file, and then so basically every process will be connected to this function, or basically every process will be running this function. So opening the file in the read-only mode, then every process will be reading the file, so reading like 4 KB at like one time, and then at the same time we'll be monitoring the memory usage. So based on the different memory usages, we will be sending different signals to the parent, and once it's finished reading the file, we'll again be sending signals. So that's like it mainly, that monitoring and opening the file. So now we'll go through the code really quickly. So basically, yeah, as I said, we open the file in the read-only mode. Again, the basic array checking going on here. We declare an array. So what this array does is, so this array basically stores whatever we read. So it's because otherwise the memory usage will not reach to 50 MB threshold, which we have set. So I just declared a macro here, because we know like if it crosses 50 MB, the memory usage will be sending a signal to the parent. So we are just accumulating everything so that the memory usage gets to that 50 MB thing. Again, the basic array checking going on if the error is created or no. And then this is just the variables which we'll be using here. And then we see, so basically here we are using the read function to read. So this is just the basic maths just to find the position in the array where the next 4 MBs, well, not 4 MB, 4 KBs, I'm just confusing it, where the next 4 KB buffer will be stored. So just the calculation for it, just finding the position where the next 4 KB will be going on, because the array will be accumulating everything. So in this one, we open this file. So the reason for opening this file is because this file contains information about the memory usage, basically, which is the VM RSS. So we open the file, again the error checking going on. So here what we are trying to do, basically we are trying to find the line which has the VM RSS. So we go through each line, and then whichever line has VM RSS, or basically the resident memory, so we just like get that and store it in the memory usage KB. And then we just check if it's greater than the threshold. If it's greater than the threshold, we print a message, we log on the message. And then what I'm doing here, so instead of the kill function, I'm using a sigq function. So the reason for this is, like as I already described in the Word document too, that if we are using kill, and if the multiple processings are sending the same signal at the same time, the signals can be overridden, and maybe one of the signals can be lost. So sigq, what it will does is it will send the signals in the queue. So we send the signal and we send this value. So the value is basically, so again, so the value is basically the worker ID. Here we said worker ID. So basically again we are using this function here for the extract worker ID. So I have just declared here. So basically again, so whatever the process is, let's suppose it is worker 2. So basically it will send the 2 along with it, so that in the syslog.file. So when we'll be logging to that file, we have that information available. We'll see after that. And then we just exit, because once it's crossed that memory usage, that threshold, we just exit the process. Otherwise it just goes on. Here we are again reallocating the array, and yeah, it's going on. Then we close it. If everything goes well, that it doesn't crashes the memory threshold, what we do is, so we printf, and then we send a signal sig user2. In the case of memory thresh, like if it crosses, we send the signal sig user1, otherwise we send the signal sig user2, and then we just exit the child. We make sure like we terminate the child after it is completed. So now we have this file for logging on to the file. So we will be creating a systemlog.log file. So what it does, again, it opens the file in the write only mode, or append or create. So basically if the file doesn't exist, it will create it. If it's less than 0, again basic error checking, we are setting up a lock here. So we have the write locks. So it will ensure that only one process is able to write to the file at one time. So basically it prevents the data corruption, because when multiple processes are trying to write the file, the data may get corrupted, or there may be partial overwrites and everything. So just for preventing that stuff, we set it, and then again the error checking if it is set or no, and then we get the timestamp here, and then we get the message here. So whatever the message is passed, we'll be logging to the file, and then again the basic error checking going on, and then we release it, because once the process is finished written to the file, we just release the lock so that it becomes available for the another process to the write to the file. And then we just fcntl fset lock, and yeah, and then basically we are just closing the file descriptor here. So that's done. So let's come to the main file. So how the things will be executed, let's see that. So first of all, I said this thing. So basically what it does is, if we just use srandom, like just if we remove this line and just be using srandom, whenever we run the program, let's suppose first time we run, second time we run, third time we run, it will be generating the same number. That so just for like generating the random data, so that every time the program is run, it generates different numbers which are unpredictable. We set this, or we can ignore this too. We have the size one, and then we just ask the user for entering the size of the file, and then this function we discussed already, it will be just generating 3 files, worker1.bin, 2, 3.bin, and then it's created successfully. And then here we are setting up the signal handlers. It's important to set up the signal handlers before creating the child process, because child process can send the signal at any time. So let's see what this function does. So here we are using just sig action, and we're using the sig handler function. Let's see what the signal handler function does is, it says like if the signal is sig user1, what we do is we are using sn printf here. So we are trying to, so we have declared this array. So we are trying to log on this message, and we are trying to store it in the log message, which is basically an array. So we are trying to just print this message. It's like storing this thing in this variable, basically, kind of. And then we have this workers completed plus. So I have declared a variable on the top, workers completed. So I'm trying to monitor how many signals till the time we have received. We'll see like the use of it. And then if it's sig user2, we just do, and then we have this function at log event, which we just saw here, so that we write to the file. So we write to the syslog.file. So we have the log message, and we are writing to it. So the basic thing, and then after setting up the signals, we are creating the 3 child processes here. So we're using the fork for creating the process. Again, basic error checking going on. If it's less than 0, printf fork failed. And then if it's 0, what we do is we just print the PID of the child process there, and then we execute this function. So basically we attach this function to the process. We already discussed the worker process, which is basically this one. So it will be reading the file, read only mode, and just like creating the array, storing it in the array, which we already discussed. And then here what we are doing is we are waiting for all the child processes to be completed. So here comes the use of why did I use workers completed. So let's try to see what's the reason behind that. So the thing is, like, we are already waiting for the child processes to be completed, but the thing is, let's suppose there is a process 1, it sends the signal, and then there is a process 2 sends the signal. So after sending the signal, like maybe the process 1 gets completed, but we know we are using sig queue here. So these signals will be lined up in the queue. So the process may have terminated, but the signals may not have been processed yet, right? So we want all the signals to be processed before the parent process exits. So that's what we're going to do here now. So let's look at it in the above. So we have this workers completed, which will increment every time we receive the signal. So since we will just receive three signals, because I think because process 1 will send one signal, either sig user 1, either sig user 2, process 2. So till the time it is less than 3, just pause so that all the signals gets processed. So that's how basically it works. So let me now just quickly jump to the demonstration part. We discussed all the theoretical portions. So I've already set it up. Let me just log into back again. So let's go, maybe increase the size. I'll just show you the different files. I have already generated the shared library file and everything is done. Let's just make it. Let me see. So we just make the files. It's compiled. Let me just clear the screen. Let me just use /main. So it says enter the size for the file 1. Maybe let's use different sizes. Maybe I use 5, and then here maybe I use 45, and then maybe for this one let's use maybe 70, and maybe let's press enter. Let's see what it does. So we can see, so first of all, these are the different process IDs which are printed here, and then we see that worker completed work1.bin. So worker1.bin was read completely, and worker2.bin were also completed, but the worker3.bin kind of just exceeded it, maybe because it's a 70 MB, just increases the size. So let's try to now, so let's do ls. So we can see we'll have this syslog.log file. Let's try to see if we successfully logged information there. Syslog.log, let's just enter. So we can see the timings there. It's I think 4 March. I'm not sure is the correct or no. So maybe the timestamp, I'm not pretty sure. It says 22. It shows 1 before. I'm not sure about that. So we can say, but the worker ID 1 completed its task, 3 exceeded. We can see here worker 3 just exceeded, and worker 2. So we can see the information is successfully getting logged. So that was the demonstration part. So if I discuss about the challenges that I faced, I would say that I was able to complete the code, but the challenges was like, for me, sometimes the child was getting terminated before the parent. I used the wait one, but it took me time to figure out that sometimes child can be terminated, but the signals haven't been processed yet because I was using SigQ. I'm basically using SigQ. So that's why for me that was the major challenge to figure out, and it took me basically a lot of time for that. Another challenge was that because I was not able to like how to terminate the child process so that the parent doesn't get affected, because sometimes I was terminating child and the parent was getting exited too. So that was the different challenges basically I faced, mostly related to the debugging part. So yeah, so if I will say, I think I implemented all the parts. Like, so for implementation of all the parts, I would say I will give me around 9, 10. I would say maybe one of the things left, but I think I did most or maybe all of them, at least to my understanding. But yeah, I think still there are many things to learn. I think in computers, like, we can always optimize the code, we can always make the code more efficient. So things, there are always like possibilities for making it better. So yeah, that was it. So yeah, I will just end the presentation now. Thank you.